This is the Amp Hour Podcast, recorded January 21st, 2013. Episode 129, with guests Brett Fox and Jerome Foundry. Device doubling Decretum.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Chris Gamble's Analog Life.
And I'm Brett Fox, CEO of Touchstone Semiconductor.
And Jerome Foundry from.
Hello, guys. Welcome to the Amp Hour.
Is this our first dual guest episode?
I believe co-located. Yeah, I think so. First dual guest episode.
There you go. Thank you very much for joining us, guys. It's not often we get a CEO and a VP of engineering on the show. So thanks for giving up your valuable time. I'm sure it takes a lot of effort to run a semiconductor company.
Yeah, we're having a lot of fun with it, and we're happy to be here.
Awesome. And we've got a whole bunch of viewer questions, audience questions, which we'll get onto. But yeah, tell us about Touchstone Semiconductor. How did it start? Where did you guys come from? What spurred you to go off and run a rebel group and form your own semiconductor company?
Well, we all came from Maxim, actually. Most of the founders and myself came from Maxim or linear technology. Mm-hmm. And the idea actually is one that started with me and had been in my head for maybe 10, 12 years, since about 2000 when I left Maxim. And the timing wasn't right then to start a company like this, but eventually... later on in the decade, it became more and more right because the availability of internet was starting to open up, and just for very essential things, plus some things that were going on in my life personally, where I was afforded the ability and kind of the umbrella to start a company like this because I got involved with some venture capital people who wanted to start a company like this. So therefore, I had the chance to get going on this, and one thing led to another. Mm-hmm. And Yaron and I and another individual who's right next door to us, Adolfo Garcia, starting Touchstone.
Right. So you said that almost like the venture capital company wanted you to start. So they were fishing, were they? They were fishing for somebody to take their money and form a semiconductor company.
They don't like you taking their money.
Right.
I'll tell you that. If you raise money, we could spend a day on just raising money, but
sure.
What they do in some cases is they bring on somebody like myself as what's called an entrepreneur in residence, and what they'll do is they'll pay you, and you'll get an office you'll get all their contacts inside of venture capital and out. With the concept being that you're going to start a company that's interesting to them. They may or may not fund it at the end of the day.
Right.
And in essence, they were interested in doing an analog company a la Maxim, and I happen to know the managing partner of this venture capital firm. So when I left my previous employer, Mike Krell, and I was looking around for something to do, I looked him up and said, hey, I'm available, and he should come up here and spend the day with us. One thing led to another, and I ended up being an EIR with them. And then that led directly to Touchstone.
What is that acronym?
EIR is Entrepreneur in Residence.
Oh, yeah, Entrepreneur in Residence. Right. This is interesting. This is the first time I've sort of heard of this, because we've had others on the show before that have raised venture capital, and it's like extracting teeth. They do it the other way around. They have their great idea. They're so passionate about it, and they try and they visit hundreds of different venture capital firms and give their pitch and get rejected by everyone. And exactly. So that's a different experience.
We had both experiences. So we had the EIR experience, which started us. And it turned out the VC firm I was working with didn't end up funding us.
Oh, wow.
And that ends up actually being, so it ends up actually being a negative because of various things. Because it's like, why didn't they fund you? And there are many different reasons that VC companies don't fund people. And it turned out in this particular instance it had nothing to do with us, but it ends up being kind of a black mark. So the other war stories that you just heard about, hundreds of VC firms and everything else, we went through all that. We were raising our money in early 2008, and if you remember the economic climate in 2008 with Lehman Brothers and all those things.
Oh, no.
That directly went into what happened with us. So we ended up finding our first investor, Gil Kogan of Opus Capital, within a month of starting to raise funding. And we're thinking, great, we've got one. And usually you find one, you find the second one in the snap of the fingers.
Right.
And didn't work out that way for us. And you need two, because we were raising, at the time, we were trying to raise $11 million, and we ended up raising 12. And as the year went on, it got worse. So we had to retrench and essentially keep funding the company out of our own pockets. And then in 2009, we started raising money again. And then late in 2009, we found Khosla Ventures with Pierre Lamond, who's kind of a living legend here in the Valley. And Pierre ended up being the second part of our syndicate. And then in early 2010, the money went in the bank, and we were up and running.
Wow.
So it's almost as if you either go one way or the other. You end up with like a black mark against your name, and you're just poisoned. The word gets around to every venture capital firm pretty quick. Or once you get somebody interested, then you get a good word passed around all the venture capital funding, and then everyone wants to jump in. Is that
kind of, sort of, but you have to remember there's another thing going on, and I don't know whether you guys have touched on it in previous shows, but semiconductor investing is not in vogue.
Right.
It's something that's been going.
Why is that?
It's expensive, man.
I have my own theory.
Yeah, I know.
I have my own theory on it, and my own theory is if you go back to the mid '90s when there were a lot of companies that were kind of one product wonder companies, where essentially they were funded, and for a minimal amount of money, the VCs were able to flip the companies and sell them for hundreds of millions of dollars. And these companies were no more than a test chip or a chip that just wiggled. Wow. And that model perpetuated beyond 2000. And after 2000, it started not working anymore. So there's an old thing about throw the baby out with the bathwater, and that's kind of what happened with semiconductors. So if you look at the two guys that fund us, Gil Kogan was an original investor in Maxim. So when we walked into Gil's office, and Gil and I had a mutual friend in common that introduced us, when we walked into his office, halfway through our initial pitch, he looks at me and he says, I was an original investor in Maxim. Wow. And boom, it was 3 meetings later and we're done. So it's very easy. Yep. It's kind of a love at first sight thing with VCs. So he fell in love with us. And Pierre, if you look at Pierre's background, Pierre was a co-founder of National Semiconductor, was involved in the funding of Linear Technology, was chairman of the board of Cypress, Microchip, Vitesse, many other companies. So unbelievable background. So when we walked into Pierre's office and met with him, it was 3 meetings and we were done. All it took was a year and a half in between, and but still, that was it.
Eating out of pizza boxes.
Yeah, exactly. Exactly. So when you find the right guy, it's absolutely love at first sight, and it's very simple, and they fall in love, and all the things you hear about rigorous they are and everything else fall out the window because they love you, and they say, wow, this is great, and they ignore all the other things that possibly can go wrong because all of these guys know that many, many things can go wrong in starting a company.
Right. Mm-hmm. Well, and usually with venture, it's often it's based on the people, right? I mean, you mentioned that you were the entrepreneur in residence. That's often the same kind of model that like on the software side that Techstars does or Y Combinator, where they choose the people instead of the final idea because they trust that the final idea will be good because of the person. Or people in the case of groups.
Not being a VC, there are different funding models that they use. One is the one that you mentioned, Chris. The other one is to look at specific areas of interest and fund various companies that are going after that specific area of interest. So they have different thought processes that they use. Yeah. It's a fascinating area. It really is.
Yeah. Was there consideration in the fact that it was fabless? That maybe our listeners don't know with Touchstone that you guys are a fabless semiconductor design company, correct?
Yes, that's correct. Yep. It's impossible, by the way, to start a fabbed semiconductor company today.
I was about to say, you couldn't, could you?
No, you can't.
It'd be...
Okay.
No.
In fact,
it'd cost $2 billion.
So
right up front.
You could start very, very tiny.
Yeah,
you could get like a second-hand Asher and Etcher and
right. So you could hire Jerry Ellsworth and she could be there individually fabbing.
And at the end of that day, you'd still be $300 million in the hole or whatever it is.
That's true.
So it won't work.
Right.
So the only way to go is fabulous. And one of the things that really changed since I originally had the idea and today is really the emergence of world-class analog technology with companies like TSMC. And that's a game changer. When you look at, and Yaron maybe can talk more about this, but when you look at what we can do with foundries versus what a Maxim can do or a linear technology can do internally, almost all cases there's no difference or little difference.
Yeah, foundries have come a long way. I mean, they'd be just purely for digital design, but those days are long gone. They have a very wide variety of process options to choose from, both in geometry as well as all the process features at each technology node. And they even do SiGe and the most obscure things that you could think of. They have technologies to support it. And analog is a big part of that. Started with power.
And what was the reason for that change?
Well, because they think and found that they can make money there, right? It's very obvious. That's why they do it.
Money, yes.
Oh, I thought it was some marvelous advance in technology or something.
No.
They just decided, no, there's money.
Yeah, no.
I can smell it.
No, it's for them. The beauty of analog is that the analog is behind the curve for the migration to tighter and tighter nodes, right? So.
Of course.
We don't need to be in 22 nanometers for most of our analog functions, and it's a great way for them to keep utilizing their fabs, the ones that run equipment from 5 years ago. So it's an interesting proposition for them.
So it was basically they decided, well, look, all the processors are all moving to these new whiz bang, ultra small geometries. So we've got all this equipment sitting around. What can we do with it? And they decided, analog.
I'm sure that's part of it.
Can still use those. So they pushed it.
I'm sure that's part of it, and that's how they started. And they started promoting it. And then many of the companies that would be their customers looked at it and said, "Well, that's not enough. What you got there, because this is, let's say, 10 years ago." And there were no good linear capacitors. There was no support for bipolar transistors. There was no matching data. All the things that analog design engineers really rely on was all missing. But they put that in place over the years, and now they're excellent.
And no thin films as well.
Have the CAD tools changed at all? Have they improved?
Yes, the CAD.
Out of sight. Is that another reason why that you can? Easily start up easily in quote marks.
Yeah, that's definitely part of it. The part of the support that a foundry needs to give you is to have a PDK, a process design kit, of that technology that you can work with and that has all these analog features. And they do. Ah,
so it's almost building block type. You can just Would you only use those building blocks they supply, or would you go to them and say, "Hey guys, we've got this weird idea for a chip. We need to figure out how to make this work"?
Depending on your size, they may do that. If they have to put in their R&D hours, then they're going to, of course, look at.
Of course, they charge you for it.
But if you can do that yourself, they may be very well willing to keep supporting that. And there's actually a bunch of companies out there that use that model.
Yeah. So, would you say that the majority of your chips use just like off-the-shelf blocks from these, starter kits, so to speak?
I would say off-the-shelf transistors. It's not like we can take an op-amp from here, a reference from there.
Oh no, okay, of course.
No, but so far, I mean, we're small, so we don't have a big R&D arm to support the device development, as in go figure out a new transistor type or anything, right? So we're using the basic building blocks that they provide, but then our skill sets, our added value is the circuit design that we do with those components.
Even though we did have one design where one of our older design engineers actually really wanted to change the shape and size of various transistors to get what he wanted, which was kind of interesting. It worked. Worked for silicon, so I give him credit.
All right. Those old engineers will get you every time. Yeah, exactly.
You know what, Chris? Those older engineers are worth weight in gold. They're a dying breed, sadly.
Oh, yeah.
But there are people out there, if you go back to the guys who started out in the late 60s, early 70s, who really understand the device physics in a way that the younger generation of designers doesn't. and they're used to really working directly with the fab and the foundry, and they are absolutely priceless to have around. I can't state that strongly enough.
Yeah, certainly true.
It's like having the old guys that write that they were writing machine code and assembly for microcontrollers, right?
Yep. So Brett, what did you what was the reason you wanted to start it? You said that you had the idea back in the 90s or something? Late 90s, early 2000s. Why were you unsatisfied with what Maxim were doing as something that they were doing wrong, or you thought you could do better?
I don't know whether Maxim. Well, you obviously think you can do something better, or else you don't do it. But it was at a time personally where I was seeing the end of the line for me in terms of what I could achieve at Maxim. I'd done a lot. It was a great company back in the day, and I have nothing but good things to say about my experience there. But for me, it just kind of felt like, okay, I have a choice to make. I can either stay there and keep doing what I'm doing, or try and do something different. And this is really what I wanted to do, and I kind of saw a possibility to get there.
Yep. So what's your take on the whole Maxim? I mean, Maxim had a reputation probably in the 90s of producing, 600 new chips a year or something something ridiculous like that, and you could never get them. They were just hopeless. They got such a bad reputation that they had to spend a long time trying to fix that. What's your experience with that?
Oh, I've lived both sides of it. I remember being there and dealing with it, and it's horrible when you're running a business and you can't supply your customers.
Of course.
It's not a fun thing to deal with at all. And then on the other side of it, competing against them, it's interesting the angst that's built up in the customer community. If you look at part of the reason why, I know there's a question about second sourcing and why did we do second sourcing. Part of the reason we did second sourcing is because it serves a need out there. And customers are unhappy with Maxim. They're unhappy with the fact they can't get their product. And we're providing an alternative and a service to customers by doing it.
So what was the cause of Maxim's demise in that area in terms of getting that bad rep? Were they just biting off more than they could chew? Did they not have enough fab capacity? Too many, designing way too many parts? And what was this?
It was not it was more of a philosophical thing. The philosophy of the company was more around the lines of, we don't believe in any customer's forecast. Therefore, if you're showing upside, we're not going to build it until we see the whites of their eyes. That's the best way I can describe it.
So they won't. So they build it to order. Basically, that was their philosophy.
Not even build it to order. It was more until it's on the books and until you desperately need it. We believe we can. There was an old saying at Maxim about robbing Peter to pay Paul. And that was kind of part of what people did there, to kind of keep things going. And I think they've gotten somewhat better. I don't know whether they've solved all their problems, but I think they've at least tried to address them, would probably be the best way I could say. Not that I want to be a mouthpiece for the competition.
Exactly. No, I remember about 5 years ago they tried to address it seriously. They tried, the CEO came out and tried to fix things. And I don't think that reputation's gone away.
No.
Because there's a lot of engineers out there who simply will not touch Maxim still because they've been burned too many times. You're designing their part and then you find you can't get it, and you're screwed. And that makes you look bad as a design engineer. So, nasty stuff. So how does a company like that produce in the order of 600 new chips?
You have
a year.
Well, it's the same. We're doing. Essentially, it's the same thing we're doing at a smaller scale. You hire good designers. You have metrics and goals. And the thing about our business, which is kind of interesting, is it's typically one engineer development effort. It's very different than digital, where a digital design maybe 20, 30, 40, 50, 100 people working on it all at once or more. Our stuff is typically one engineer per development. And from one, you get many. So from one development effort, we may develop 5, 6, 7 parts from that one development effort.
What sort of variation can you get on, say if you design a basic op amp, what variations can you do in terms of, can you do different power grades or what?
Yeah. So are you talking about off one design, or are you talking about
off
once you have one
single
design, what other things could you do?
Yeah, as Brett just said, yeah, you put the effort into producing one design and then you can get half dozen variations of it. What sort of variations can you get?
With amplifiers, it's one of the things that you mentioned is definitely there. You can vary the amount of power that you put in, and with that the speed characteristics of the amplifier will change. And change common methods that are used. Right, you can make it unity gain stable or 10x gain stable. You can of course do things like put duals and quads on the die, but that's typically a different, the same design effort, even though it's a different layout, right? But it's still, you leverage the design effort have been put in already. And that's amplifiers, and amplifiers are probably not even the best example for doing this. There's other things where you can go in many different ways.
So what is your biggest product? What is your biggest area at the moment? Is it amplifiers? Is it references? Or what is it?
Our most successful are the one where we most put most of our effort.
Yeah, your most successful products. Have you found it's amplifiers? People desperately need second source Maxim amplifiers.
Well, I would say at a high level, we're seeing interest across the board for what we're doing. Everything we have is selling.
Right. Okay.
Everything we have has customers' interest. There's no question about it. What we have seen, which has been a real positive surprise for us, is our assumption at the beginning was it was going to be very difficult for us to sell our proprietary parts at the beginning. That was another reason we started off doing second sources. But much to our surprise, we've seen a very willing audience for everything we've done on the proprietary side right from the beginning, which is really, really nice to see. We were expecting it.
Well, I wouldn't have expected it either, because as a design engineer, I'm going to, who's Touchstone? I don't know. I haven't used their parts before. Are they going to be around in 5 years' time? If I design their part in and it is a custom part, I can't second source that anywhere else. Well, that's a big risk on my part as a design engineer. So generally, I would only do that if I had a very niche need and your chip absolutely nailed it, and there was nothing else, on the market to do it. I find that quite surprising, as you guys did. So you seem to be building up more of a rep in that area of, you can actually supply them in volume, and, people are getting a good vibe that you're still going to be around in 5 and 10 years' time.
Yeah, absolutely. Absolutely. In fact, the other thing that I was expecting, which didn't occur, was I was assuming at the beginning I would have to personally close a lot of the business, especially the big orders that we got. And I haven't had to close any of them, which is, again, fantastic, which means we can leverage, which is what you need to scale and grow a company.
Right. So how many different parts have you got?
We have now 62 parts in the marketplace.
Today.
62 today.
Yep.
And
right. And that's after what, two years in business?
Yeah, 2 years in business. And by the end of this calendar year, we'll have well over 100 parts in the marketplace. We're growing by leaps and bounds.
Yep.
I just find that amazing that, you can put one engineer on a, on a new chip, and out pops a new chip, and you can produce 50 or 100 in a couple of years. That's just
more than one engineer.
Just amazing. I thought,
there's
more than one, and they're working hard.
I'm sure you've got more than one engineer, but
we're very fortunate in that the team we have, I would say, pound for pound, if I was to use a boxing analogy, pound for pound, I think we have the best team in our industry. And I've been blessed to work with some really good people, and this team is the best I've ever worked with, bar none.
Have you found it's hard to get new blood out there? Is there enough engineering talent coming out of the various unis and things like that?
We'll both take a stab at it. You can
Yeah, so I was going to say that first of all, it's hard. It always has been hard, and it's supposed to be hard to some degree, because we're looking for the top of the line people. As far as universities goes, it's a little bit the same. I mean, there certainly has been a shift over the years from what was just electronics to much more digital design. And in that process, the analog side has been forgotten in some places. But there's still a whole range of universities where there's excellent analog schooling going on. They're both inside the US as well as in Europe and outside of Europe in Asia as well. So there's still plenty of people coming out. Now, the typical person that we would be interested in this phase of our existence has already a couple of years of experience behind him, because we need people, just like Brett said earlier, that run their own project, that run their own design, and that have done that. If you've looked at the folded cascode amplifier in a course of analog design in school, that's great, but that's only a start. We need people that have done that in some form of industrial environment a couple of years. That's where we're looking at now. But there's still people out there.
So it'd take a graduate who's at least done some semiconductor, fab theory and design stuff in their course. So it'd take them at least a couple of 3-4 years on the job before they could sort of start actually designing their own chip and taking on the entire project?
Yeah, that's correct. Before that, you can do blocks, and that's and eventually,
right,
that's also we're going to be looking for like that a couple of years down the line. But at this point, we need people that are a little bit further in their career already.
Yeah, and then just to add a little bit more color to that, the typical engineer for us has about 20 years of industry experience and roughly about 10 patents per designer. So it's a pretty experienced group that we've had.
Okay.
Yep. It's not your typical 20-something startup type company, It's a little different.
Yeah, of course.
Yeah, we got a bit more gray.
So do you think it's an area that... yeah. Do you think it's an area that students should get into? Do you actually recommend? Is there always going to be a future there? Is there a high-paying future guaranteed jobs?
I think there absolutely is, because one of the other fundamental things about analog is there are more opportunities than there are designers to solve all the opportunities. And regardless of whether it's IC design, level design, doesn't matter. In analog, we live in an analog world, right? Mm-hmm. Analog's not going away. So I think it's if you want to be an engineer,
of course. Yeah.
If you learn analog, you can learn anything else. It's a fantastic area to go into.
It's just fun, right?
Yeah. Right. I agree.
No, but it's without a doubt. I agree 100%. It's been, if you look over the last couple of years, we've during the all these economic troubles that we've had, the situation were harder for analog design engineers as well. But the employment situation was never. I would say there were always for good people. There always have been. There have been looking. There have always been openings. So yeah, I would recommend it.
And you can earn the big bucks, I'm assuming.
Yeah.
There's big money in it. Yeah.
Yeah, there's nice money in it. I mean, but that's not the right reason.
You can
to
always
do it.
name your price, couldn't you? Well, yeah, of course, but I mean, these are young kids we're talking about here, right? They all they're thinking about is money sometimes.
I hope not.
Do you find that it's the passionate ones who are the good designers, like the ones that have an interest in it outside of work, or do you find that you can actually get those who just don't give a toss about this outside of work and that's just their 9-to-5 day job?
Well, I'm sure the latter. I'm sure they exist, but the first one is a much bigger group. Many of the people that we have here are the type that you described first, that started off as a kid and were hobbying around and have just a passion for analog electronics, and that from one thing came another, and somehow they got in school and still were doing the analog stuff and then got a job in there as well. And they just go for it. Their passion is to make it work and then to see it sell and end up in somewhere where somebody else uses it. That's what they go for.
Do you think that you'll always be an analog company as such? Is there any, oh God, I wish we could do this chip, but it needs like a DSP core or something like that?
I think we'll always be an analog company. I think if you look at kind of one way to look at us,
right,
even though we're not really competing head-on-head with them, is linear technology certainly would be a grown-up version of what we may become. We'll see where we go, but more like them than we're the turn that Maxim has taken, I would say.
By looking at your product portfolio here, you seem to sort of, you're doing amplifiers, ADCs, and low power, stuff, all that sort of thing. Is that your area of expertise? I mean, I don't see any RF stuff, for example.
No, that's correct, but that's not because we do not have the expertise. We actually do have people that are very skilled RF designers as well. It's just that we found that there is a niche in this very low power area that we got a lot of product ideas that we want to work on first. And at some point, I'm sure we're going to go into different directions as well. It's not a dogmatic choice going to be only doing low power, not at all. But there's things that need to be done that we think we're going to do. So,
how do you come up with what chip you're going to work on next? Do you research the market and go, oh, that one's, Maxim aren't supplying that one, but we think there's a big need for it, and do you target like that, or do you just go, hey, we think this one's cool, let's do a new, let's do the world's lowest power, voltage reference or something like that?
Yes and yes. So we definitely are talking to customers, understanding what's going on, and we're creative guys too. So we have ideas, and we have regular sessions with the designers and our apps guys to talk about what we think are the right things for us to go after, and those meetings are very dynamic. And from that, we kind of distill out the best ideas. Right now, we have about 10 times...
Dynamic?
Yeah. We have about 10... very dynamic, actually. And it can get pretty fun in those meetings, actually.
In lots of arguing.
It's my favorite of all the meetings we have here. That's my favorite one, because when you see people come up with really good ideas, ignoring the arguing, which also can be fun, by the way. Yeah.
Yes, it can.
That's when you get,
as long as there's beers afterwards.
You can get super, by what's going on. So we have about 10x the ideas that we have designers in the company to solve them right now. So we're not idea limited at all, as it should be.
I bet.
So you guys play in the low power space. I mean, you're not actually in any of the DC to DC kind of stuff that seems very en vogue because of just the need for LED lighting and everything else like that. Why aren't you in that space at all?
Well, and see what comes.
Wait and see.
We might see some DC to DC converters coming from Touchstone.
Yeah.
Whoa,
okay.
Whoa.
Interesting.
I would have thought that market would be absolutely flooded.
Yeah.
I mean, there's so many DC to DC converter options, but as always,
Right,
I can never find the ideal one.
You're right, Dave.
I'm doing my parametric search on DigiKey, and right.
So you know what, Dave? You're 100% right. That's
crazy.
Part of the reason we didn't go after DC to DC at the beginning is because so many people playing in that sandbox. So it's a big sandbox, but you have to kind of figure out where you want to play. And the bottom line is for us, is if we can add value, we'll do it. If we can't add value, then we're going to move on to the next thing. So we found areas where we believe we've got some groundbreaking stuff where we can add value in that space, and that's what we're going after.
You guys have just signed up with DigiKey, I believe, to distribute your parts. Is that an easy thing? Is that an easy thing to do? Do you just approach them and go, "Hey, do you want to sell our parts?" And they go, "Oh, we've already got 20 million manufacturers,"
No.
Or is that their philosophy to absolutely have every single manufacturer?
I think their philosophy is they want to have every single manufacturer that's selling. And they have to believe that you're going to be a viable player for them to do business with you. So that was a several-month courtship that went on between us and them, to make that happen. It wasn't like, send something into their website and then boom, you have a list and you sign up. That took a bit to make happen. But we love those guys and we love their model. And we know that almost from day one when we started selling our first part, customers were asking us, are you on DigiKey's line card? And, it is absolutely...
I'm surprised everyone would be asking you that.
Yeah, and everybody was.
If you're not on DigiKey, you don't exist.
That's a very good statement. Basically. So now we're on DigiKey, so now I guess we exist. So
Yay!
Yeah, exactly.
Yay! I can find your parts now, because as a design engineer, that's my first port of call, DigiKey or Mouser. Usually DigiKey because it works a bit better and they have a bit bigger range. But yeah, that's how it works. That's how you find your chips. And then if you get desperate and you can't find it there, well, then you might start searching out the individual manufacturers. But 95% of the time, bang, I'm going to find a suitable part on DigiKey. Parametric search every time. So, do you have, so once you're in with them, do you get all your products automatically added, or do you have to convince them for each new one?
No, they're all on there. All 62 of them are on excellent. Their website, all in stock. They're, as I said, they're fabulous to work with, and we're really happy with the relationship.
Mm-hmm. So would they normally want to buy like a reel or two or worth of each part?
Yeah,
is that
absolutely. So they want to make sure, because their whole shtick is, they make sure that they can get parts from them to you anywhere in the world in 48 hours, I think is their goal. So they don't want to have to call us and say, gee, we need a reel of this. And it defeats their whole model, I think, to do that.
Of course. So are you on Mouse or others, or are you just targeting DigiKey at the moment? Like a new
we have DigiKey. In terms of the catalog guys, it is only DigiKey, at this point. And we don't have plans right now to add anybody else but DigiKey. We also have Future as our worldwide distributor. And then in Asia, we have World Peace, WPG, which is the largest distributor in Asia. They just took us on. And if you go to their website...
Never heard of them.
Yeah, World Peace is actually, they're called World Peace or WPG Group. They are the largest distributor in Asia. So that's a real sign of confidence that they've decided to do business with us as well.
Are you allowed to say where your main market is? Is it Asia, or are you selling mostly into Asia, or are you selling into mostly the US and
mostly
European
at this point,
markets?
because of our distribution presence and our sales presence has been really North American centric at this point. So it's primarily been North America, some Europe, and now we're starting to see growth in Asia as well.
We've got a whole bunch of questions. Should we get onto them, Chris? Unless you've got more.
I had one.
Yeah.
Because of your rollout schedule. And I don't know if any of the listeners asked this. How long is your qualification process? I mean, I know that. So you said 62 parts. There a lot of those seem like there are different flavors of a base design, and then they like different voltages for references and stuff like that. But how long does that qualification take? Because I mean, I've never really done any of the chip design side of things. How fast can you roll stuff out?
Yeah, once you have silicon out, there's a bunch of things that need to happen, right? Design engineer needs to take a look at it in the lab and see if it wiggles, if it does what they expect to do. And let's assume that it does. Then in parallel, test engineering is working on creating a program to do the production testing, which is a different world, of course. They need to get their things done. And then parts that have been tested with finalized test program would need to go into some qualification. But that qualification doesn't last that long. It can take up to a month, right? We do what most companies, most IC manufacturers do. We do 1,000-hour burn-in on our parts, and that's the longest pole in the tent. That's the thing that takes the longest. And besides that, there's things like isnt testing, chip testing, and a bunch of other stuff. But the operational life test is the one that takes the longest. But in the grand scheme of things, that is almost never the limiting factor. It's getting all of our work done on time and get everything everything lined up for a proper product introduction and announcement to the outside world that takes most time.
Yeah, I'm sure it's a symphony of.
I could imagine that you would have more people working on that side of thing than actually designing the chips. You'd have more people in the test and qualification and production engineering side.
No, it's not the case. No, we certainly right now our company is very heavily it's leaning towards design. That's where as it should be in this phase, right? We need to get products out, so that's where we are staffed the strongest.
Where do you draw the line on what characterization testing you do? Because I'm sure there are some like really anal customers who want a characteristic curve for absolutely everything. They want drift versus temperature versus voltage versus, does somebody fart on the other side of the room?
That's a weird chart if you guys ever...
Yeah, well, remember that one.
I have to say we haven't come across many ridiculous requests yet, but and it's again, we want to be a company that is. Yeah, I'm sure we will. Yeah. We want to be a company that's easy to work with, and we try to accommodate from customers as well as we can. But typically, as an analog supplier, there is thousands of customers, potential customers out there, and we have to be able to communicate with all of them without physically talking to them. So it's key to get a lot of this information out through typical operating characteristics in your data sheet or app nodes and things like that. That would be the preferred way of doing it.
Okay.
Because I can imagine that every customer would have a particular spec of that product that is important to them, and then another customer will have another part of the spec that's important to them, and all the other specs don't really matter that much. I can imagine that's very difficult, because you would have to try and put in as many characteristic curves for as many aspects of the product as possible.
The latter is certainly true. If you talk to our apps engineers, I'm sure they would agree with you that there's a lot of these curves
right.
that need to be measured. But the first part, I'm not so sure. But people do care about the same features, right? They care about the speed or propagation delay or bandwidth on one side, and then they care about how much power do I need to spend to get that, and what's the accuracy?
And how much does it cost?
Yeah, well, obviously that's the first one. How much does it cost?
Right.
Otherwise, I'm not even.
These days,
that goes back to your DigiKey search that you were talking about.
Yeah,
right.
Right, of course, you search by search for function and then price.
Yep. Absolutely.
Sort by ascending price.
Yeah.
Is that something you're targeting? Are you targeting the low cost space as well, unlike Maxim, who are pretty much a premium price supplier?
I don't think we want to be, never to be considered to be a low end manufacturer is good. I think we want to be considered a reasonably priced manufacturer for what we're giving people. We can't give it away because we got to make money too. But we don't want to be these guys selling LM324s or whatever for 8 cents or whatever they'll for these days. That's not our deal.
Yeah.
Speaking of the cost, and this actually takes us into our first listener question. There's a lot of costs behind all that stuff, like you said. But one of our listeners, Carmen, asked about if there's any plans to, do like really large app notes, like Jim Williams style. You said you were emulating, you hope to one day, grow up to be similar to LT. I mean, is that going to be on the app side as well? Do you see that pushing more sales? And
absolutely. First off, I don't think there'll ever be another Jim Williams. He was a very unique and talented individual. Having said that, you can certainly take bits and pieces, incorporate that into your own personality and the personality of your apps. And we have some pretty prolific writers who are brilliant engineers on the apps end who are writing very nice app notes now, and will continue to do that because it's both important for customers and it's important for us to the brand to do that.
Okay.
Is it hard to find good apps people like that? I can imagine it would be.
It is.
It'd be harder than finding actual designers.
If you ask your own, he will tell you from his experience. It's kind of funny. He and I have this debate all the time about this, and his feeling is it's harder to find a good apps guy, a real good strategic apps guy, than it is to find a really good designer, which tells you the import of finding good apps people.
Yep, I certainly believe that. Yeah.
How would you define a good apps person then? What do you look for specifically for any of our listeners that might want to be one one day?
That's exactly right there, right? How do you exactly define it? It's somebody that has experience doing board design, somebody that has affinity with the way that the ICs are going to be used, but they also need to understand what it takes to actually design the IC. They may not have to be able to do it, but they do need to understand enough of it, know what is possible and what's not. And that's that's not something we talked about schooling earlier. There's PhDs that are working on the most advanced IC designs, right? There's no real school that you go to become a very good apps engineer. You have to learn that in the field by working. So it's
School of Hard Knocks.
It's difficult to find.
And you've got to have a passion for that. You've got to have a passion for just building stuff up and building different things up, seeing what this chip is capable of, thinking outside the box, and using this 555 timer for 20 million different applications.
Correct.
That's really
hard.
So
we want to, part of what we do, which was somewhat alluded to regarding characterizing our parts is we road test every single part we do, to the specifications and beyond, because we want to see where it's going to break, how it's going to work, and in different ways. Because I think Dave, you were making the point about different specs are interesting to different customers. Also, you'll get customers pushing the limits in ways that they shouldn't. And you want to make sure that there's kind of soft failures, not hard failures for your parts when that happens.
Uh-huh. Are your specs typically conservative then?
Yes.
Yes,
like
they
your
are.
absolute maximum specs
Yes.
conservative?
Yeah, no, but
So if you go to 6.1 volts over the 6, it's not going to
I don't think there's a lot of companies out there that dare do that nowadays. It's a very dangerous game to play, right? Because it bites you really badly. Yes, we are conservative, but that's no different if you go to companies like Maxim, LTC. They're all doing that.
Yeah, right. Yeah, you can just go, I can drive 100 milliamps out of this pin. No worries, she'll be right.
Well, it's tough because specmanship is just a tough thing in general. I mean, because there's even shades of gray with, are you specing typical? Are you specing maximum? And then there's the art of reading that as the the board level designer and trying to figure out, well, Touchstone is known for always specing maximums, and then I can squeeze out a little more, or they company X specs typicals, and I don't trust them as far as I can throw them. It's just what you come to know about a company. So it's who actually does that specification then? Like, is that just the group in general? Is that like the characterization group?
It's essentially a contract between the designer, the product definer, and marketing. So those three groups have to agree on what the specifications are going to be when we launch a product, so that we make sure we're all in sync. And then if there are fundamental changes from those, which do happen, I mean, as much as we like to say that we know what we're doing and we're going forward in the right direction, things do change and stuff does happen. And if there are fundamental changes where we can't achieve something, then we have to agree, or else, we're going to stop the project, which is a rarity. We haven't had that happen here yet at Touchstone, but it does happen. And where you see people, get in trouble is that they'll let projects go, and then you have your oh shit moment, where suddenly it's oh shit, it costs twice as much as it should.
Right.
Oh shit, the specs are 2 times as worse as they should be, or whatever it is. And then suddenly, guess what? You don't have a product that's going to sell, or you don't have a product that's going to make money, and that doesn't do anybody any good.
I wanted to ask a question about Chinese parts. Like, you were talking about like an LM324 before, and how, well, you probably wouldn't touch like an LM324 because they're tuning them out for, half a cent in China. Who's actually tuning them out for that price? Are there actually these mysterious Chinese companies who, churn out these jelly bean generic branded parts that you'd find in, some little, toy, kids' toy at the... Or what? Have you got any experience with that at all?
No, I don't. So I don't know of anybody doing that, but certainly there is a portion of any business, which is the jelly bean portion. And there's probably somebody out there making there are enough guys probably making LM324s or 555 timers out there where there's somebody doing it for nothing,
right.
Or thinking they can. There's the other classic of we'll make it up in volume type thing.
Yeah,
where somebody thinks they can make it up in volume. So maybe there's somebody out there doing it.
That's a lot of fun.
I don't keep track of that part of the business at all.
Right.
The old saying, "How do you make money selling free stuff?" Volume.
Yeah, that's right.
Right?
Yep.
Yeah. All right.
Well, speaking of other companies, one of our listeners, oh boy, this is a Reddit name, so I'm not sure what it is. Fat Angaboo was asking about other. Right, you're gonna get that online, I guess. But what some of the other analog startups, and some of these I've actually never heard of. So Linear Integrated Systems, That Corporation, and Solid State Microtechnology, which was later
that corporation?
THAT, yeah, that.
Seriously, that's their name?
I guess, yeah. I've never heard of that one. That one.
It sounds like someone you'd get on the shopping network.
Yeah.
A company selling the latest Abdul.
Yeah.
From
I'm
that
sure
corporation.
that is probably an acronym
Right.
for something.
Right.
Yeah,
I'm
I don't know
sure
what
it
it
is,
stands
but-
for, but
It's an acronym.
Yeah.
For some of these guys, I had to look them up because I hadn't heard of them. But that is an audio only company that took over they are not fabless. They do have their own fab. They took over a fab that was once Cypex's a long time ago. But that's a 4-inch line, so that works only if you work on small volumes, very high margin parts. So it's a very, very different business model than what we have. They've been around for a long time. They've been doing this for 25 years. So whatever they do seems to work. But our goal is very different. We want to touch many more customers and grow substantially faster.
No pun intended.
Yeah.
Touchstone. Is that where the name came from? Can you explain the name?
Yeah,
How did you come up with it?
In a thesaurus. So if you look in a thesaurus and you type in Maxim,
We need a name.
into it. You need a name. So we go, hey, we're going to be Maximish, so let's go type in Maxim into a thesaurus. And if you look at the various acronyms for Maxim, Touchstone's in there.
Wow.
And
Really?
it was the best one, and it kind of had a cool feeling to it, and you couldn't really peg it to one thing. So we liked it, and that's the one we went with.
Oh, that's terrific.
Man, we're in good company here, Dave. This is like how we come up with show names, like our funky
it's
show
brilliant.
title. So
I love
maybe
it.
we'll have to type in Touchstone and see what comes up for that for the show title today. Wow,
There you go.
Oh, boy.
that's great. Well, so to get back to the we were asking about the app engineers. And there's no school for that kind of thing. But the someone else had asked about what you'd look for aside from the 20 years of experience. Obviously, is there anything else that you look for in the analog designer side, or is it just mostly the experience and the patent portfolio?
Well, there's a spectrum in there. I'll let Yaron answer it, but there's a spectrum in there regarding that. Yeah, there's a spectrum in there in terms of the years of experience. So what he was talking about was the minimum that we would look for. But you've got kind of your thing in terms of what you guys look for on that end.
It's as I said before, we at this point we need people that have done their own design, have brought out their own, taped out their own design at preferably at another company and got some industry experience.
Okay.
It doesn't have to be 20 years. That's certainly not. But a few years, yes. But if I think there was a question that was all about how do I prepare myself for a career in analog, and definitely you start out with if you still figure that out before you choose your college or university, then go to a place where that's actually something that they care about. So, and you find that out by looking. Is there anybody here that pushes things that is moving the needle in terms of analog design? And that's where you want to be, because that's where, from working with people like that, that's how you learn it. And then when you come out of school, then companies like us and companies like Linear and Maxim and TI, they're going to be interested in talking to you. And then once you have a couple of years experience at a company like that, then once again you build it up, right? So that's how it goes on.
Sure. Speaking of patents or patents, as you Yanks call them, what is that important to you? Are patents important to you in terms of your product portfolio?
Yes.
So you're fans of the patent system. Is that good for getting more venture capital funding? We're
not fans of the patent system at all, but we have to use it. Right. And unfortunately, in this day and age, it is so important because it's both defense and offense at the same time. Yeah. So you need patents because there is an old saying, and the old saying goes like this: if you're a semiconductor company, at some point, guess what? You're going to get sued. Even if you don't intend to, and you're not trying to infringe on somebody's patents, somebody's going to come after you and somebody's going to take you to court for something. So, the more portfolio of patents you have, the more you have to trade. And then on the other end, when your portfolio gets big enough and you get strong enough, guess what? You can become the hunter.
You can start being the big the big daddy and suing every bastard. Yeah. Oh, great. Vicious circle, huh?
It is. I mean, the patent system does in our country is horrific. Let's be honest about it. But we have to deal with it, and that we're not going to change it.
Would the goal for you guys to be every new design, somehow you'd be aiming for a patent on that?
Yeah, that's probably a good way of putting it. It's not a goal in itself. The goal is to come out with a product that's going to sell.
Yeah.
But as a rule of thumb, that would be about it. Yeah.
And typically, what aspect of it would you patent? I mean, if it's an op-amp, clearly you can't, patent an op-amp. Would you patent a couple of transistors in this configuration, or?
Yeah, it could be as simple as that. It could be something that's very much on a transistor level, where you say, okay, well, the way that I'm using the transistors in this configuration is new and not been, and that gives me these advantages. But it could also be, and those are actually the better patents the stronger patents are the ones that are more on a system level. They're stronger because they're easier to detect if somebody else is doing it, right?
Of course. I was going to say, well, that's the other thing, right? If you patent how a couple of transistors are configured, how do you know that somebody hasn't done that somewhere? I mean, just the sheer odds are that, yes, somebody's done it somewhere, and published it in some obscure magazine 30 years ago,
Yeah, that could be. And then that opens up a whole other can of worms. Because if you find that out after the fact, but it's also from a protective point of view. It's only if your performance becomes so much better what you could do without that way of doing it, otherwise you would never find out if anybody else is doing it, right?
Got it. Yeah, of course. We've got another question from Jose Kieran. I think that's correct. And he asks, what development tools do you use for IC design?
We're using Cadence almost exclusively. We have some other EDA vendors that whose tools we use as well, but the majority of the suite is Cadence, both front and back. So both for schematic entry and simulation as well as for layout. Is
there a reason for that? Were you familiar with those tools, or was they simply the best option by far?
I'm more familiar with the bigger names, so with the tools from Cadence, tools from Mentor, and some of the other players. But Cadence I think it's fair to say that they're still the touchstone of the EDA world, right? They're the standard, and we enjoy working with them. So it was a natural choice.
Yeah, and there's actually one other aspect to Cadence too. When you're recruiting, it's interesting, but designers ask you the same question. About what's your tool set, and because Cadence is so well known in the analog world, it's actually a recruiting tool they have to be using Cadence as well.
Of course, yep. Because there's only really two major players that you would consider using, Cadence and Mentor, right? Is that probably true when you're doing a startup semiconductor company?
That is correct. Yep.
Yep. And how much do tools like that cost? It's probably you probably can't say, but it's millions, right?
We can't say. What I will say is, in terms of capital expenses,
of course. Yep.
It's one of our highest capital expenses that we have.
That's what I would have thought. Yep.
Yeah, it's very expensive.
Well, what expenses would you have? You would have wages, and you'd have CAD tools, right? That's
mass
probably
cost.
It. Is that
mass cost?
Oh well, of course, mass costs, of course.
Wages. Yeah. Which fortunately for us, we're not in deep submicron, so we can actually afford to do what we're doing. Yeah, we got to manufacture, but that's different story.
Yeah.
What's the price difference between like the masks that you're doing and masks for high end, really
millions,
low feature size? Millions.
It's in the millions of dollars difference. Yeah, we can get ours for relatively cheap. And it's all relative.
As in what, under 100K, or
depends on
100K?
It's somewhere in that range, I would say. It just depends upon what we're doing and who we're using. But if you're looking at doing something deep submicron, that's well over $1 million to do that.
Wow.
And that's why that's the other reason why you don't see a huge amount, especially of digital companies coming out in the startup world, because you just can't afford to do it. It's just too damn costly to get there.
Yeah. How confident are you in your tools that when you push that button to produce that mask that it's going to work? And the other question is, the flip side of that is, how often has it gone wrong?
Your own right now. The answer to this one.
Because that's the question that asks me every time that we have to sign a PO to purchase another set of these masks, right? But yeah,
Yep.
so with the tools nowadays, you can catch almost all mistakes. Not everything, but almost everything. So
Right.
it's very unusual for us, and that's not just over here at Touchstone, but it's unusual to get your parts back and see that they're just dead, that they don't do anything.
Right. Okay.
It's
But it has happened, has it?
We
Or
had an interesting.
has it happened at least
I'll tell you a
once?
story about
Yeah.
that actually. So the
Please
first
do.
part that we ever did was the 1001, which was designed by your own at night
That's
and
right.
on the weekends. And our foundry, we got it back. We were so excited. He and I were in a conference room. We could see the truck coming with the wafers. So he goes and runs into the lab. I go run after him, and he's like, "I've never had this happen before.
yeah.
It's nothing's functioning." And I was saying, "Boy, maybe something's wrong." And it turned out, after a couple days of investigation, that our foundry vendor had inverted a mask layer
Yeah.
and caused the whole thing not to work.
No.
So it cost
Do you
us.
get a refund for that?
Well, what happens is they fix it at their
Oh, good,
cost,
good.
but
Yeah.
you don't.
Yeah.
The
At their
killers-
expense, yeah.
The killer, by the way, guys, the killer's the time. Because
Oh, yeah.
the one thing that you're fighting in
course.
starting a company is time more than anything else. So when you lose that time because of a mistake, be it yours or somebody else, it's not like in software where you can just respin the software and out it pops the day after.
Yeah.
When we have a mistake, it's several months. So it was brutal for us when that happened. It really, really hurt.
You guys make board level problems look even easy compared to that, right?
Yeah.
Yeah.
Oh, board
Exactly.
level's easy. You can spin a new
Yeah.
board in 24
Yeah.
hours if you want. You just pay
Yeah.
extra money and you get a new board in 24 hours. How did you find that mask was inverted? What steps did you go to when you finally realised? Did you have to look at it under the die under a microscope or what? How did you?
It's all of the above. You measure, you look at the die, you look back at databases and masks that were generated, and eventually you found it. There's as difficult as problems are to find on an IC. In the end, you always find it. This one wasn't very difficult,
Right.
actually.
Yeah.
Yeah, well, you
Yeah.
had to. Was that the last thing that you would have thought
It's
of?
not. Certainly, it wasn't the first thing that I thought of. Let's put it that way. You think like, oh, maybe it'll
Exactly.
oscillate, or maybe it's
Yeah.
right. Your typical problems, but
Yeah,
this
yeah, of
wasn't one
course.
of the
Yeah,
ones
yeah.
that we had in mind. But yeah,
Because if you power it up and just nothing happens, that's the worst
Yep.
kind of
it was
fault
not a
to
happy
troubleshoot,
day.
isn't it? Oh, sometimes it can be. No.
Wow.
Well, on your first ever part, did that really? Did that make you think twice about getting into this business? Like, oh, is this how it's going to be?
No,
You
no,
know?
not really. No,
you
You guys
no,
have
no.
experience, so that helps.
Yeah. We've seen.
When
things
you've
like
been around as long as we have, you've seen it. So it wasn't what we expected, but you know what? It's life, and you just go deal with it and you move on.
As a fabless company, how hard is it to grab the ear of the actual fab? Because I would think that, especially when you're starting out, it would be tough.
It's a great question, Chris. This is where having good investors really helps. So when it comes to the people that we have around the table, both in our investors and our board of directors, many of us have personal relationships with the senior people at these foundries. So we're fortunate enough, because we have those relationships, that we can get the ear of the foundry. The thing that you're doing is one of the other things that, if you're doing what we're doing, you're always constantly, selling your company to somebody. And what I mean by that, you're telling your story on just about a daily basis, just like we are to you guys, to somebody. And, part of the reason, work with a TSMC, for example, TSMC is very picky about who they do business with. And if they want to do business with you directly, they want to be convinced that it's worth their time, because what they'll tell you is on any startup, they're going to lose money. So it's an investment for them and their time. So they wanted to believe in us. And with the relationships that we had, we ended up telling our story to Rick Cassidy, who's the president of TSMC North America. And Rick's been a big supporter of us almost from the get-go. Because he's an ex-national guy, believes in the analog model, and believes in us. And it's been a very good relationship with him. It's been a good relationship with our other foundry vendors as well.
Huh. And so do you guys spread it around? I mean, I don't know how much you're allowed to say about that kind of thing, but
We'll say a little bit, yeah. So we do.
Okay. We do. We have several foundries that we work with.
Okay,
I think
it's smart.
And why? What's the reason for that? Just, covering all your bases, make sure you've got second sources in case they're
all of
busy
the
at the
above.
moment?
It's partially it's to get features that one doesn't have, you go to another, and it's also to cover your bases.
Okay.
It's all of the above.
Right.
Oh, that's very smart.
So when you design a chip, you would have a particular foundry in mind. You'd be
definitely.
using their toolkit.
Yes, definitely.
Is that?
Yeah.
Have you seen any of these found? We've had a couple questions about the more out there not geometries, but topologies, I guess, with silicon carbide and graphene and everything else. Have you guys started looking into that side of things, or is that kind of more ways off?
Even if we would want to, we can't. Like you said, it would need to end up with the foundry first before we can do anything with it. And graphene is definitely still in the rich. IBM did a lot of work on it a couple of years ago. I think MIT did some things.
Yeah,
and it's all very promising.
Yeah.
It's
a very small market. There was an
yeah.
article interesting enough today about graphene, I think in EE Times Europe, and I think the market size for it is maybe $125 million today. So if you look at the overall semiconductor market, it's a gnat. It's not anything at this. Maybe someday, but not yet.
Yeah. Well, you mentioned SIGI
very
before,
good mobility,
right?
So that's good.
Yeah.
We've had an ongoing discussion in quote marks on this show for the last 2 years about something Chris brought up, and I'm going way back in one of our early episodes. He made the claim that within, what was it, Chris, 5 years, we would have chip printing machines on our desktop.
Printing machines.
And I wanted
3D printing,
like as in, as in you could print your own chips.
Oh,
right. There's Chris has gone offline, so he can't defend himself here. This is great. Chris claimed that all of these. Yeah, we would have printable electronics, right? So that you wouldn't be buying chips from the component manufacturers like you guys anymore. All of the designs would be online. Everyone would have their own little chip printing machine, and they'd you'd print out your new chip. And Chris said, "Oh yeah, it'll happen in 5 years." Here he goes. He's back.
Yeah,
we're having mumble problems. And I called complete bullshit on the idea. I said it wouldn't even happen in 20 years. Have you guys investigated the printable electronics?
I think I'm more in the
area?
I think I hate to say it, Chris, but I'm more in the bullshit camp on this one. So sorry about that.
Yes.
See, now this actually has some weight behind it. That's the problem.
Non-believer.
Yeah, well, when a CEO of a semiconductor company tells you that hurts. But you know what? I'm going to hold out hope. And I'll.
You might be right,
complex.
but it's going to be very much for small things that are not too complicated, because the geometries have to be, by the very nature of it, have to be very much scaled up again.
Right.
So the quality can never be what you can do if you have what you can do on silicon nowadays.
And how can you beat it? I mean, the component availability these days, you go on DigiKey, how many hundreds of thousands of parts are there for every conceivable application, and they cost like $1. I mean, there's, average, I don't know, the average chip cost might be a couple of bucks or something, but, like, how can you beat that? You can't. There's no point having a machine that will print chips yourself, because they will be uncharacterized, they'll be untested, they'll be all that sort of jazz. So, really, you can't beat being able to buy a 50-cent microcontroller, for example.
And then you also have the issue of how you're going to package them and how you're going to cut them.
Yeah.
Exactly.
Scissors.
Yeah. Scissors.
Speaking of packaging, so I win that one. That's just, I just want to confirm that I win. Chris, do you formally give up?
He's offline again.
He's offline again. He can't defend himself.
By definition, Davey's given up. So.
Right. He's quit the entire radio show business in protest. All right. Speaking of chip packages, what do you have favorite packages? Do you find that your customers want the more, like the really ultra small packages, or do you always make a thing like, we're going to make it available in an SO8 or something that, because we believe that's important?
I think the general rule is smaller is better. Yeah, everything's shrinking, everything's smaller. So
no, don't tell me that.
Yeah,
it's depressing.
Yeah,
well, maybe it's a good time that they could bring up their. You guys have a lot of breakout boards available and demo kits, right? I mean that's a cool program you guys do.
Yeah, absolutely. So we try and make everything we do available with demo boards, and we're relatively pretty easy to get them from. So we're trying to be very liberal with that. We think it's an enabler for our customers. So people ask for them, generally we'll give them away, and we're certainly giving away free samples every chance we get. Plus there are vendors who have, in fact, we have an app note on our website about this, vendors who have available from SO to DIP type things where you can do, so you make it a little bit easier to evaluate, parts.
Yep.
So do you find that those free samples are really suck in engineers? Are we that easy?
Yeah, I hate to say it, but go back to your Maxim experience. It's one of the positive things that we learned from Maxim is Maxim did that worked really well for them. Now, what we're doing that's different than Maxim is our parts are actually available, but but you give people something.
Wham! Take that.
So exactly. Wham! Maxim guys, take that. But it is a good, simple thing to do that makes it easy for people to do business with you, and that's what we're essentially trying to do.
So when you bring out a new chip, would you go, right, we're going to manufacture, how many would you manufacture up front, even though, I assume you'd have no initial orders when you do a chip? You just think, we'll put it out there. Would you manufacture 100 reels, or what? What is the sort of minimum you would order from a fab?
Well, you've got multiple wafers that you have to do. So about the minimum run that you can do is 12 wafers, depending upon the die per wafer that you get, especially in this day and age where most of the foundries are 8-inch wafers. You're getting a hell of a lot of parts, initially. And then you make use, in today's world, liberally of die bank. So from die bank, you can build out in 4 to 5 or 6 weeks, depending upon your back end.
What's this die bank?
Well, die bank is, if you can imagine, you're holding either in wafer form or die form your product. So it's prepackaged.
Oh, okay, right.
It's prepackaged. Right. Yep. And then you package it up. Sometimes, especially with us, we may do some personalization of the part, post-package.
Yeah.
Laser trimming
cuts and stuff.
Yeah, we're doing various trimming types things that we might be doing. So it gives us a lot of flexibility, and we can get parts to a customer very, very quickly. It also, which is a very pragmatic thing, is it limits our, I'm trying to think of the right word for it, but it limits our downside, so to speak, where if things don't go right, we're not sitting there building up a lot of stuff and the cost suddenly goes way up. In die form, it's cheap. Yeah. In packaged form, it suddenly gets a lot more expensive. So
once it's put in a package, it's not just that, right? Then you also test it. So now it's the fully loaded cost.
Yeah, of course.
Whereas if you keep it in as a weight, it's, much of the cost hasn't gone in yet.
Yeah.
So what would the cost breakdown be compared to the wafer, the packaging, and the testing? Because they're the three major
percentages, you mean, right?
In today's world, this is, I think, one of the other big things that you can think about, because it does vary from part to part, by the way. So in general terms, the definite cost is more in the packaging than it is the die today. Mm-hmm. It has changed significantly from when I first got into this business. I think about Maxim back in the day, we were on 5-inch geometries, if you can believe it, with 4-inch wafers. 4-inch. Yeah, so the cost was much more in the die than anywhere else. But it's changed a lot.
Are there any questions that you saw on here that you wanted to answer, guys?
I don't know. The examples of other companies that were out there were all companies that have been around for 25 years. They're not really exactly the same type of companies that we were at.
The only other comment I would make, I don't know whether it came up in one of the questions or not, is that I think we are the last, or one of the last, semiconductor companies that you're really going to see that's venture-backed, that's going to build to scale. It is, I hate to say the word dying, but I think it's...
Really?
It's just because you look at, if you go back to the story I told at the beginning of how hard it was for us to get our funding, and we were a pretty experienced group with a pretty good reputation. It's very, very hard, and it's very difficult for various reasons, and we could do another amp-hour show on that. It just seems to me from the experience that we've been through that maybe there'll be another one that comes along, but I don't think there's going to be a lot more. I don't expect there to be a big resurgence in semiconductor companies starting, even if we're successful. I don't expect that, to be what happens. I think, for various reasons, the heyday of the semiconductor startup is probably passing, which I think is in one sense good for us because it means there's going to be limited competition. Taking my touchstone hat off, I think it's bad for our industry because that means there's going to be less innovation, which is sad to hear.
So where do new companies come from then? Would that just be from like spin-outs and
right,
stuff?
You think
I don't think you're going to see very many new companies. I think that's part of the corollary.
Right, so we're stuck
pretty much.
with what
I think
we got.
you'll see the odd one or two come out, but I don't think it's going to be, the large group that it was years ago. And that's disappointing. And I hope I'm wrong, quite honestly. I truly do.
So no China upstarts?
Well, it's interesting. There certainly are more in Asia than there are here. You could look at China, you could look at India. They certainly have tried the analog model over there. Hasn't gone great. In fact, there was a trend in the early part of the last decade of the Chinese analog startup, in theory, because the cost of engineering is so low, and those things looked great on paper, but the reality was they didn't work because the engineers couldn't get anything out. So it just didn't end up happening. So the few companies that ended up doing that route didn't succeed. The one company that does stand out in my mind that kind of has somewhat of a model like that is Monolithic Systems, if you're familiar with them. They're actually an American company based here, but they have a large design center over in Asia, if I'm not mistaken. So they may be, but they've kind of stalled because their model's kind of narrow. So, but they have made it and they are public, which says something.
Do you see any more consolidation in the market?
Almost by definition.
Right.
Yeah. Almost by definition, that's going to continue happening. There's no question about it. There are
even major ones like TI buying National?
We'll see. You have to be a soothsayer to have said you were going to see that one come.
Yeah.
Who knows the real reasons why it happened or what. And it's not clear yet whether that's going to be successful for Texas Instruments as well. We'll see.
Of course.
Typically, the other thing of our industry is typically mergers don't work very well. You have a lot of it is you have a community of designers that's used to working a certain way, and you merge that with another community of designers which is used to working another way, and typically it's like oil and water, they just don't mix.
Culture clashes,
typically
right?
most of the culture clashes, and we'll see what happens. You got a Texas culture with Silicon Valley culture. They are different. Those companies were major rivals for many, many years. That's going to take some time to sort out, probably.
I agree.
What would you guys do if you were approached for a buyout?
We're not
Panic?
for sale.
Not for sale, yes.
Not for
That's
sale
what we
now,
want to hear.
But the reality is, I say that laughing because if the price is right, then of course we're going to listen to it.
Yeah,
the reality is, at this stage of our life, is anybody who wants to buy us is going to try and buy us not for the right price. And it's just the way the world is. It's a buyer's market, not a seller's market. So for us, there are a couple things about us. We didn't do this. We were talking earlier about making money and all of that, and we certainly went into this with the goal, obviously, of winning. But if we wanted just to make money, all of us would have stayed at Maxim or Linear. That wasn't why we did this.
Oh, okay.
We
did
this
personally wanted to make money.
Yeah, we did this because we believed in what we're doing. We thought this would be something that was, fun. I don't want to use the word glibly, but we thought we would really enjoy this and have fun with it and make it a very successful standalone entry, which was part of our goal here. And it's part of why we have a diversified business. We're not just in one area. We were thinking of the future when we started the company. We were thinking of the long term when we started the company, and we didn't want to be a one-trick pony, which is why we're doing it the way we're doing it.
There you go, kids. That's the lesson for today. If you want to start a semiconductor startup for money, it's a mugs game. Don't bother.
That's right.
Oh, boy. I've got another question. We were talking about the die before. Do you guys, if you've got leftover space on a die, do you put in a little picture of an animal in there, or do you sign your names on there, or Is that allowed? Is fun allowed at Touchstone Semiconductor?
Farm animals, right? We do the farm animal thing.
Yeah. There's I've seen a couple of examples like that. Yes.
But there is something we do. No, not here. But we do something fundamental though. We do maybe not between the die, but we will do test chips. And what we will do is carve out a few die if we've got something going. In fact, we just did that on a development effort, because if you want to test something out before you see silicon, you can take a block and you can put it on another die intended for something else. If the tape-out times meet, and then you can get a first look at something. And it does give you a step up, because as great as the simulation tools are today, there's nothing like seeing silicon.
Just like having a board in your hand.
Exactly right.
What would be typical differences between that you wouldn't see in simulation that you would get on die? Is it oscillation, or is it excess power consumption, or is it?
Yeah, it could be all of the above, but it's typically has to do with parasitic coupling that wasn't perfectly modeled when you did it, and then
as in from transistor to transistor, like you get capacitive coupling or something.
Yeah, from transistor to transistor through substrates or wells or what have you, and they can play tricks on you.
Is that just due to the process tolerances, manufacturing tolerances on the die? What is that?
No, it's
or they just haven't got the model accurate enough.
Yeah, it's if you imagine it, that's difficult to grasp in a model. That's what we use tools that are called layout parasitic extraction that try to grab all these features and put it into an electrical model. But there's a limit to what you can do there.
I think we're almost up on our questions.
All right.
Have we gone through them all? Have we covered them all?
We have one more, just kind of a general future predictions. I mean, where do you guys see the sensor market going? I mean, you guys play in the sensor market a lot, but where do you guys see tech going in the next 5 to 10 years?
Technology as a whole, I think, there's the classic. It's going to be smaller, it's going to be lower power, and it's going to be cheaper. I mean, that's the general thing I would say that we're going to see happen. I think you're going to see, even for us, even though we're not it's funny, there's all this talk about integration these days. We're going to be integrating more and more, as will all of our competitors, just because the feature sizes are shrinking. You'll see, from a company like ours, which we truly hope for, the beautiful thing about our world is that it's not a static world. So there's going to be new functions that nobody ever thought of or dreamed of. And hopefully we're going to come up with our fair share of them, and they're going to lead to new market opportunities and new things that, board-level designers like yourself can do. And that's where, from our perspective, we get so excited about the future, because we know and we can see some things, and we've got some things in development which, nobody's ever done before. And those are the ones that, can lead to, not all the time, but can lead to real groundbreaking things, lead to major shifts in the way people do things. So that's what we're excited about, and that's kind of what we see.
Do you guys have like a slogan or anything like that?
We do. If you go to our website, it says we are the 21st century analog IC company. And the general concept of that is it's...
Oh, trademark.
Yeah, trademark, yeah. Look out. The thought process was, one, it separates us from all of our other competitors who were started in the 20th century. And it also points out that we are new, we are modern, and our whole thought process, which we've talked about a few times in our discussion today, is we want to be really regarded as being easy to deal with. We're not trying to put barriers between ourselves and our customers. We're really trying to make it simple and easy. I know we're not going to be perfect, but having said that, we are really striving hard to make the process of working with Touchstone one that is enjoyable for our customers and for us.
And I noticed that you sort of strategically added high performance in there.
Yes.
To make it even a longer slogan, not just the 21st century analog company, it's high performance in quote marks. Why?
Well, because
why did you add that?
Trademarks have a minimum word count to them.
Oh, do they?
I'm just kidding, Dave. No.
Right.
It's because we are also a high performance analog company. So, we wanted to make sure we got that in too. So.
As opposed to a jelly bean company.
Yeah, it wouldn't be too good to say we are the 21st century jelly bean analog company, so we figured we'd go for the high performance angle. And, and after we had
nice work.
And after we had a few beers, it sounded really good. So we went with it.
Right. And who designed the logo? Did you shop that out? Or
that actually a friend of ours did it for free. So
there you go.
Hey, when you're a startup and get something for free and it looks good,
it
works.
Bonus.
So that's why we did it.
Absolutely. Are you going to be one of those companies that bloody change their logo on the chip?
We will not.
Every year.
Let me put it to you this way: we are not going to change our logo to green. And it's not going to have some silly little M in the middle of it, like somebody else might have just done. No, we're not going to do that. And we're not going to pay somebody God knows how much money to do that. No, I think we like our logo. Logos
think of the consultants.
Yeah, that's right. Think of the poor consulting business.
How are they going to feed their families?
I'm not with Touchdown.
That's right.
Awesome.
That's what we like.
Although your chips are too bloody small to put your logo on them these days. You can't even put the bloody part number on.
T's all you need.
What's up with that?
It's the way of the world.
That's one thing that bugs me. Can you have like a list on your website, like a tab on the side that says, decode the stupid number on the top of the chip, and then,
the little orphan Annie.
Is there please, can you do that?
I know we have it somewhere.
Because
it's funny that you mentioned that, Dave. I know we have it somewhere. I can't remember where it is, but I know we have it. And I kind of feel the same way.
It should be on the front page.
Somebody has to look at these damn things. I don't know who does it, but somebody does. So.
Well, because I'm tearing down a product. And I'm looking at these chips, and people want me to explain what the chip is, and I've just got to say, well, I don't know what that chip is. Makes me sound like a bloody idiot. Because it's just got some obscure number on it that I can't Google.
Yeah.
No. Well, thank you very much for joining us, guys.
Well, thank you. It's been fun.
Thank you very much.
Yep.
I think we're way over. We're like an hour and a half.
Yeah.
Oh, wow.
But we do like to go over with our guests.
So
Unless
people
you've got
can
any last-minute questions.
No, we're good. No. So thanks a lot. We're happy to do it again if you guys want.
Yeah, we look forward to all the new parts. It should be very exciting.
And you guys have samples, free samples,
demo boards, free demo boards, free apps assistance. Not free parts.
And you're on DigiKey now.
And we're on DigiKey.
Right.
Yep.
Awesome.
Great. And on Twitter at Touchstone Semi and
That's right. On Twitter,
.com.
we've got a Google Plus account now, so you can find us on Google Plus. We got a Facebook page, so
Great.
We are definitely social media friendly.
That's awesome.
Good work, guys. All right, thank you very much for joining us. It's been awesome.
All right. Take care, guys. We had fun.